Integration by substitution. So we're going to look for this pattern. If we can find this pattern here, which is this is a composition of a function, and then this is the derivative of the function inside the composition of function. Another way of looking at this would be f of u prime. Okay, so for example here, I guess it's usually best to start with g of x. So does it make sense for this example here? G of x would be x squared plus 1, where f of g of x would be x squared plus 1 squared, where f of x is equal to x squared. Okay, another way to write this, you can let this be u and let this be f of u. Usually that's kind of the notation I like to use. So notice we have u is equal to x squared plus 1, and f of u is equal to x squared plus 1 squared. So u prime is going to be equal to 2x. Now I can substitute everything in here. Okay, so the form here, this is going to be f of u times u prime du. So f of u is going to be x squared plus 1 squared. U prime is 2x dx. Okay, so you can see how I went from here to there. Okay, so what we're going to do for this problem, notice here that this is the same thing as the derivative of u with respect to x, 2x. So I can make this du equal to 2x dx. So now looking at our original problem, x squared plus 1, I'm going to call that u squared. 2x dx, I'm going to call that du. And now I can take the antiderivative of u squared du, which would be u cubed over 3 plus c, where u is x squared plus 1 cubed all over 3 plus c. Let's try another one of these. Hopefully we'll get better as you see more examples. Okay, so this one here, so first of all, I'm going to let u equal 5x, and then notice that the derivative of u with respect to x would be 5. Thus, du is equal to 5 dx. So this will be what I want to use to substitute into this integral. So the 5 to the 5x power, let's see, the 5 and the dx, that's going to be my du. So that's going to be du. E, I'm going to leave that as e, and then 5x is u. Now I can take the antiderivative of this. The antiderivative of e to the u would be e to the u plus c, where u is 5x plus c. Let's look at example 3. So we got two functions here. This one is the composite function, and x is just a linear function. So first of all, I want to let u equal the part of the function that is inside the composition function. So this is going to be x squared plus 1. Then I take the derivative of u with respect to x, which would be 2x. So du equals 2x dx. Okay. Now the problem is, let's see. For 2x dx, I have an x and I have a dx, but I don't have a 2. So what I need to do, I can manipulate this a couple different ways. I can do this. I can say, all right, let's make this 2x, which changes the whole problem, but then I can also multiply it by 1/2. So now it's equivalent. So now the 2x dx, I'm going to substitute that in. So I got 1/2. The 2x dx, that becomes du. The x squared plus 1, that becomes u squared. And now I can take the antiderivative of u to the second power. So I'm going to have 1/2. U to the second power would be u cubed over 3 plus c, where this would be u cubed over 6 plus c. And then u is equal to x squared plus 1 cubed divided by 6 plus c. And that would be our answer there. Okay, example 4. Example 4, this is the composition of functions, right? The f of g of x, or f of u, is going to be the square root of 2x minus 1. So I'm going to let u equal 2x minus 1, where the derivative of u with respect to x will be 2. So du equals 2 dx. I don't have 2 dx, so I'm going to put in here 2 times the square root of 2x minus 1 dx. And then I have to multiply it by 1/2 to even it out, to make it 1 again. So now 2 dx, I've got 2 dx right there, and u is going to go right here. So I'll have 1/2 the square root of u du, where this is the same thing as 1/2 the integral u to the 1/2 du. Now I can find the antiderivative, so I have 1/2 out in front. Then I have u to the 3/2 divided by 3/2 plus c. So this is going to equal 1/2 times 2/3 u 3/2 plus c. 2's are going to cancel out. So now you got 1/3 u. U is going to be 2x minus 1 to the 3/2 power plus c. All right, let's try 5. So for 5, again, I'm going to let u equal 2x minus 1, where du dx is going to be 2. So du is going to be equal to 2 dx. So I don't have 2 dx. So I'm going to write in here 2x times the square root of 2x minus 1 dx times 1/2. So now I have the 2 and I have the dx. I also let u equal 2x minus 1, so let's do that. So now this is going to be equal to 1/2. The 2 and the dx, that became du. So it's going to look like this to start. So now the problem is this is with respect to x, or with respect to u, and there's an x there. So I need to get rid of that x somehow. I can use this guy to solve for x. So I can rewrite this as u plus 1 equals 2x, where x would equal u plus 1 over 2. So now I can substitute right there and write 1/2 times the integral, where x is going to be u plus 1 over 2 times u to the 1/2 power du. And then I can factor out the 1/2 here. So now I got 1/4 u plus 1 times u to the 1/2 power du. I can distribute u to the 1/2 power and get u to the 3/2 power plus u to the 1/2 power du. And now I can find the antiderivative. So it'd be 1/4. This would be u to the 5/2 2/5 plus u to the 3/2 times 2/3 plus c, where this would be equal to 1/4. 2 times u is 2x minus 1 to the 5/2 power all over 5, plus 2 times u, where u is 2x minus 1 to the 3/2 power all over 3, plus c. So that would be our answer for that one.